We've got a new power supply for our field of our alternator. Formerly we were using that variac and a step-down transformer, and in normal modes of test we were using a 5-volt field, but upon further inspection we found I can't do this. Pardon the camera work, folks. We found that we had quite a significant DC ripple using 120 microfarads. To remedy this situation, we now have a regulated power supply. That unit's over $300. It's a regulated power supply. And from there, we found that that supply would produce 7 volts. And when we put the 7 volts through the field of the alternator, it produced 23 to 27 volts stator output. That voltage was too high, so what we've done in consideration for that, to get a workable level of experimentational voltage, we've placed 2 large resistors, 4 ohm resistors in series. Those are in behind the scope. I don't think we'll be able to see that very well with our lighting. But those are some long resistors in there behind the scope. And then even then, after we placed our 666 machine on the outputs, we found that a ripple existed, and so we took the 120 microfarads formerly used as a DC cap filter and then incorporated that into the cap system. And so now we're going to look at the ripple from that DC field supply upon connection and disconnection of the filter capacity that we have now added. Right now you can see it's a pretty clean wave, and it's showing just over a 2-volt field level. Circuit itself, we found that this level of a 2-volt field will give us 7.9 volts open circuit and 9 volts on phase 2. The system was unbalanced. Currently, on an output, what we have is an air core transformer lighting a neon bulb. Demonstrate that real quick. I have a tremendous problem with vision. There we are. There's the secondaries on top, probably about 1 inch above the system, and we'll go in there and lift that secondary, and it should be able to see the meter showing how much amperage we're driving from the system. Try to get some more light. As I said, there's our meter. I can see the meter better now. Meter's showing a sporadic 120 milliamps. Here's the air core secondary and the effect from the system. Now we look at the system parameters for this air core transformer. To begin with, we'll look at the input voltages. I think I would be getting used to this by now. We have 7.4 volts, 7.3 volts on phase 1 with the voltage rise of 5 volts. On phase 2 we have the higher 9.1 volts. It probably hasn't even dropped from its open circuit condition, and it's rose to 18 volts internal voltage rise. And then on the third phase, we have a 6.6 volts. That's a drop from 7.9 open circuit, and 3.34 volts. That's the voltage rise. On the amperage side, then, on our stator lines, we have 4.3 volts in the middle and 4.3 amps in the middle, pardon me, 2.8 amps on one side and 0.93 amps on the third side. These are respective phase amperages. And we see we still have the problem of stator line 1-2 at 4 1/4 amps is supplying 0.168 amp to phase 1 and 0.7 amps to phase 2. That would be 2.3 amps, yet that stator line is reading 2 amps over what it should be supplying to those phases. And that should about finish it out then. We need to do one more thing to show. You'll see there on our phasing arrangement, white is phase 1, blue is phase 2, and red is phase 3. Our secondaries are shown by quarters. So we have 3 of these same style segments as that secondary, and there's actually a third quarter should be underneath that stack front facing us to show the position of those secondaries. Right now those secondaries are in a closed loop, and we don't have an amperage meter right now to be able to show the amperage of that closed loop, but we can establish that closed loop of amperage underneath our secondary is actually a second order transformer reaction, and that series secondary that's underneath of it was shown that blue checker, the second part of the segment, that is directly over the 666 primary system. So it has to go, it is the net result of the influence of the reaction of that secondary, and to show the difference in output, then we can go ahead and disconnect that amperage flow. Now you should be able to see less of a continuous output with and without the secondary gauge as a full primary. There's red, there's red. And I would say we have demonstrated the air core transformer pretty sufficiently. Thank you.